Hey Opties! Today we're talking about how to graph functions given an equation. We're going to talk about two methods to do this. One is to look at our transformations and apply them with our x and y changes for our coordinates. And the other is simply to just choose some x values and substitute those into your equation to evaluate the function to figure out the y values that correspond to those x values. Both are great methods. The second method, using a table of your own creation, which is basically just function evaluation, will work for whatever equation you ever have. However, if your equation is written where the transformations are easily identified, you may like to use the transformations method. So it's good to know both. Let's take a look at our transformations. When graphing a function from a given equation, one method is to identify the transformations and then apply the rule of the transformations to the graph of the parent function or the table of the parent function. So let's look at this example. We've got y equals -2 times the quantity of x minus 1 squared plus 3. So we have lots of different transformations happening. We've got a negative out front, which is an x-axis reflection, a 2, which is a vertical stretch by 2, a -1 inside our parentheses, which is a horizontal translation to the right 1 unit, and a +3 on the outside, which is vertical translation up 3 units. So we've got those 4 transformations happening. So one thing you could do, which is very similar to how we did our practice problems in our transformations practice video, is you could graph your original function, which would be your parent function, and then you could apply all of the rules of your transformations to those points. So that's what's happened down at this table below. If you have the point 0, 0 of your parent function, the point -2,4, and the point 2,4, there are several things that happen to it. Let's look at the step-by-step first, and then we'll look at what happens totally. Because you could do it all at once as long as you line it all out. So for your x-axis reflection, you're going to multiply your y's by -1, which is the same way of saying you're going to change the sign of your y values. For vertical stretch by 2, you're going to multiply your y values by 2. For a right 1 unit, so it's a translation to the right, that is going to be adding 1 to your x's. And for up 3 units, translation up, which would be vertical translation, you're going to add 3 to your y's. So what you could do is look in your column for x value change and then just simply add 1 to all your x values, which is what we've done here. And then you could change the sign, so multiply by -1 and multiply by 2 and add 3. So essentially, if you're multiplying by -1 and 2, you're really multiplying by -2, which is what's happened here. And then you've also added 3. So doing all of that gets us our new points, and you can plot those points to draw your new curve, which would be your curve of your transformation function. Let's look at our tables. So when graphing a function from a given equation, another method is to make a table and plot the points. To get the points, just pick some x values and substitute them into the equation to get the corresponding y values. So you're really just applying the rule of function evaluation. You get to choose whatever x values you want. It's a pretty good rule to choose some that are negative, probably 0, and then some that are positive, because most functions will have some values for both sides of your x-axis. So we're given this equation to graph, which is the same equation we had over here on our left, and we just pick some x values, -1, 0, 1, 2, and 3. So just one negative number, or 0, and then 3 positives. And so we just substituted -1 for x, and we got -5. So that's our new point. We substituted 0 for x, did all of our calculation, and got 1, and so on. So we've got our new points. It's the green. So -1, -5 is a point. 0, 1, 1, 3, 2, 1, and 3, -5. So you can plot these points and draw the curve, and you're done. So it just depends on what you think's easier. But like I said before, this making the table and doing a function evaluation with choosing x values will work no matter what kind of equation you have. So if your equation doesn't really show you the transformations very well, which some forms of equations don't, then this is a great method to use. We see here on our graph that we have plotted all the points we found from our function evaluation. And let's take a look at this point to ponder. When choosing points, start by picking some negative, 0, and some positive to get a good range. Now, I say range is a loose term. Really, technically, it would be a good domain, right? If you're talking about x's. Now, when I said the word range, I wasn't even referring to range in terms of what your y values can be. But either way, just so you can get a good, just different points. If you plot some and you cannot see the shape of the graph, pick some more on the side you need. So let's say you only chose 1, 2, and 3. Well, then you would only have this side of the function, and you know that a parabola either looks like this or it looks kind of like this. So you would know that you need some to the negative x's to fill in the rest of your shape. So then you would just go about picking a few more points to make the shape of your graph show up. Let's take a look at some practice. So we'll do number 1 for our transformations method, and then we'll go ahead and do it for a table method. So looking at this one, there's a 3 multiplied out front and it's greater than 1, so it's going to be a vertical stretch by a factor of 3. So a square root function would be 0, 0, and then the square root of 1 is 1, and the square root of 4 is 2. So here are some original points, and we're going to be affecting our y values, so we're multiplying our y's by 3. So 0 stays the same because it's our x, and then 0 times 3 is 0. So it stays 0, 0. Now let's look at our point 1, 1. It's going to be 1 and then 3 because we've taken that y value of 1 and multiplied it by 3. So 1, 3. And then 4, 2 becomes 4, 6. Because we've done that 2 times a 3. Here is our new graph. Okay, so that's just going to be y equals 3 times the square root of x. Now, if we wanted to use the table method, we could just choose some x values. So we're making ourselves a table. We're going to figure out what our y's are. So y is 3 square roots of x. Let's write down what that would be. Let's just pick some x's. If you're thinking about what type of function family you have, it will help you pick your x values. So we know that this is not going to exist for any negative x values because that would be a domain danger zone. So we only need to pick some non-negative numbers. So let's pick some x values that we know are going to have nice numbers when we take the square root of them. So you kind of need to try to be kind of smart about choosing your x values so it comes out nice for you, if possible. So square root of 0 is going to be nice. The square root of 1 is nice, and the square root of 4 is nice. So that's actually the x values we had here. And that's nice because we chose them for our parent function because they did have a nice number when you took the square root of them. So that's why I chose them. So this is going to be 3 times the square root of 0. Square root of 0 is 0. 0 times 3 is 0. Okay? So now we've got 3 times the square root of 1, which is the same thing as 3 times 1, which is 3. And 3 times the square root of 4, which is the same thing as 3 times 2, which is 6. So here are our points. 0, 0, 1, 3, and 4, 6. So it's the same graph, and it should be because it's the same problem, just 2 different methods. Let's look at number 2. So we've got a plus 2 on the outside, which is going to be up 2 units for our transformation. So let's start with those good points we did for our parent function above because we've got another square root function. So 0, 0, 1, 1, and 4, 2. Now we've gone up 2. So this becomes 0, 2. So that's our new point. Instead of 1, 1, it's 1, 3. And instead of 4, 2, it's 4, 4. So here's our graph. So pretty easy. Let's take a look at number 2 over here if we're using a table. Again, we want to choose some x values that we know are going to be pretty nice numbers when we take the square root of them. And we'll write our entire function equation here. We're going to choose 0, 1, and 4. So we've got the square root of 0 plus 2. And that's going to be 0 plus 2, which is 2. So 0, 2 is a point. Now we've got the square root of 1 plus 2, which is 1 plus 2, which is 3. So 1, 3. And we've got the square root of 4 plus 2, which is 2 plus 2, which is 4. So 4, 4. And here's our function. Let's look at number 3. Now we have a cubed root. And we've got more than one thing happening. We've got a -4 on the inside and a +4 on the outside. So the -4 is going to give us right 4. It's a translation to the right 4 units. And the +4 is going up 4. So let's pick some nice cubed root numbers. 0, 0. Let's think the cubed root of 1 is 1. Cubed root of -1 is -1. The cubed root of 8, let's do that. 8 is 2. And the cubed root of -8 is -2. Yes, it's off the graph, but that's okay. So here's our general curve. And we want to go right 4 and up 4. So let's take this 0 and go 0, 0 and go 1, 2, 3, 4, and then 1, 2, 3, 4. So here is the new point that used to be the origin. And we're probably not going to really need these outer points. So let's see what happens. Let's do our 1, 1. So that's going to be right 4. So 1, 2, 3, 4, and up 4, 1, 2, 3, 4. You could also just say, okay, well, I know these 2 points are right 1 and up 1 away from the origin. So really, you wouldn't even have to travel this point right 4 and up 4 if you just said, okay, it's going to be the left 1, down 1 from the origin piece, which is, this is the new origin. And you could get it that way. So this is kind of hard to graph based on the grid we're given, but it looks something like this. And you could go about saying what these points are. That's going to be 4, 4. This will be 5, 5. And this will be 3, 3. So those are those 3 points. Let's do a table method for the same equation. So knowing that 3, 4, and 5 are nice numbers, we could substitute those. It's kind of cheating because we already knew they worked out that way. But you could check them. I'll show you what I mean once we do this. So let's do the cube root of 3 minus 4 plus 4. That's going to be -1, right? This cube root of -1 is just a -1. And -1 plus 4 is 3. So you could think, okay, well, what x value is going to give me a -1 and a 0 and a 1, since those would be nice numbers, right? So you could do that, and the way to do that would be to do this. X minus 4 equals -1. To figure out what your x value would have to be, there's one of them. And you'd have to say x minus 4. If you want to get to 0, your x value would have to be 4. So you're seeing that 5 and 4, those are good ones. And if you wanted it to be -1, x would equal 3. So you can see how you get all 3 of those by saying, okay, I know the cube root of whatever's inside of my cubed root. That would need to be a 0, a 1, and a -1. So you just have to make x fit that, which to me is like way too much work. I would so go off of transformations on this one. but you may not be able to foresee that. So it's totally doable to do this table, but just kind of think about that. It's good to know both ways for situations like this. Let's continue. The cubed root of 4 minus 4 plus 4. So it's a cubed root of 0, which is 0, plus 4, and that's 4. Now we have the cubed root of 5 minus 4, which is going to be the cubed root of 1. Don't forget we're adding 4. So 1 plus 4 is 5. So now we have these points. 3, 3, 4, 4, and 5, 5. And it looks something like that on the ends. And you would need to know the curve of a cubic to really know how to fix out your ends. You don't want to be going all crazy up here or something. So if you needed to choose some other points, a little bit more to the left, a little bit more to the right, then that might be a good idea too. All right, that's it for graphing functions, notes, and practice. See y'all next time.